The third FRQ in the 2015 AP Calculus AB exam. It was a question that used a table of values. It's a non-calculator exercise, and there are 4 non-calculator problems in this exam. The mean for this exercise was 4.43 points out of 9, which was the second highest FRQ mean score among the 6 exercises. There's question A, question B, question C, question D, and they were worth 1 point, 3 points, 2 points, and 3 points respectively. Let's have a look at the question. So first of all, we notice this table of value. You'll recognize this very soon. There are many questions like that. We are given t in minutes with selected values here, and v of t is a rate. It's in meters per minute. Questions you must expect when you are given a table of values is to find Riemann sums. So you'll have to find areas of rectangles. Is it going to be RRAM, MRAM, LRAM? Is it going to be trapezoids? It's going to be one of these 4 and maybe 2 of these 4. So be ready for that. Notice that the base of the rectangles here are not going to be the same. We'll see that when we have the question, but the base here is 12, then it's 8, then it's 4, then it's 16. So we'll have to be careful when we add the area of these rectangles. Also, when the intervals are not the same length, we cannot use the trapezoidal rule. Anyway, let's read the question. Johanna jogs along a straight path. For t between 0 and 40, Johanna's velocity is given by a differentiable function v. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. So we'll go straight to question A. Just before we do that, notice that the function v is differentiable, so that may be useful at one point. We have to pay attention to that. It's not just continuous, it's also differentiable. Question A. Use the data in the table to estimate the value of v prime of 16. If we look at the table, t equals 16 doesn't appear here, so how could we even find the derivative at the point at t equals 16? Well, we can't, but we are asked only to estimate that value, and the best way to do that, the best way to find the slope at t equals 16 is to find the slope between t equals 12 and t equals 20. 16 is exactly in the middle, so that's for sure what this question is about. So we want to find rise over run between these 2 points here. So let's see what students did. The first students we will look at wrote v prime of 16 is approximately equal to, and this is rise over run, so 240 minus 200 over 20 minus 12. Then the student simplifies and writes the answer, which is 5 meters per minute squared. Well done to remember to write the units. And that was worth 1 point. The second student did the same work. They didn't write that it was approximately equal. They didn't write the units. However, they still earned 1 point. So in this question, the evaluators decided that the unit was not worth a point, but don't expect that to happen. Always write the units. The third student got the right idea. Rise over run. Unfortunately, 20 minus 12, the student wrote 6 instead of 8, and that messes up the answer, and this time no point. So very sad. Just for stupid subtraction, the student lost 1 point. Question B. Using correct units, explain the meaning of the definite integral in the context of the problem. Approximate the value of the integral using a right Riemann sum with the 4 subintervals indicated in the table. The first student wrote that the integral represents the total distance in meters Johanna traveled between times t equals 0 and t equals 40 minutes. We discussed that there are three things you need to do when you answer a question like that. You need to state what the concept is, you need to state what the units are, and what the interval is. So if you look at this answer carefully, we see that the concept is the total distance. That's correct. The absolute value of the velocity is the total distance. If you had the integral of the velocity without absolute values, that would be called the displacement. So total distance is correct. The units are meters, which you can find somewhere looking around. So here meters per minute. So if you integrate, you're going to have meters. You also see that the student stated the unit of the interval. It's in minutes. And number 3, the interval from t equals 0 to t equals 40, or between t equals 0 and t equals 40. The student did all that, so they earned 1 point. Let's have a look at the second part of this question. To approximate the value of the integral using a right-Riemann sum, we are told to use 4 subintervals. So there are 5 points. That makes 4 subintervals. We have the first subinterval from 0 to 12, then from 12 to 20, 20 to 24, 24 to 40. For each of these rectangles that are created with these 4 subintervals, we have to use the right endpoint, and be careful, we are using the absolute value of the velocity. So the first rectangle has a base of 12 and a height of 200. The second rectangle 8 times 240. The third rectangle 4 times 220. And the last rectangle 16.150. Notice this subtlety here. The value at t equals 24 is negative 220. So it looks like Joanna is jogging backward, coming back on her steps. But total distance, we take the positive value. It's the absolute value of the velocity, so you have to write positive 220. The student adds up all these values and gets 7,600 meters. So it was correct. The answer is correct. The first point was earned because the student chose correctly the right endpoint for his answer, or her answer, and then the answer itself was worth 1 point. Let's have a look at our second student here. Again, concept, units twice, and interval. The concept is the total distance. The interval is from t equals 0 to t equals 40. There are no units anywhere. At least the student should have said that the total distance was in meters. Also, the student should have said that it was t equals 0 minutes, t equals 40 minutes, but at least meters. So here the student didn't earn a point. In the second part of the exercise, the student did a correct work. He or she added the area of the 4 rectangle, writing a positive value for the third rectangle, and got 7,600. No units again, however, the student got 2 points. Our last student wrote that the integral is the total distance traveled, including when Joanna jogs backward as positive distance. So that's a good point. Joanna is going back on her steps. Maybe she dropped something, maybe she's whatever, maybe she saw someone. Anyway, that adds to her total distance traveled. So, but if we look at the 3 things you need to do, the student only mentioned total distance. There are no units, no interval, so that earns no point. The student then calculates the approximation for the total distance, and there's a tiny mistake, sadly. The interval for the last rectangle is 16. The student wrote just 6. So they didn't earn one of the 2 points. They got 1 point. It's kind of nice. Notice here that the student doesn't even find the value of this, and that is okay. That's not why the student dropped a point. If you leave arithmetic expressions like that, you can still get full credit. So the point dropped comes from here. Question C. Bob is riding his bicycle along the same path. For the first 10 minutes, Bob's velocity is modeled by the function given here, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at t equals 5. So this function is the velocity. How do you find the acceleration when you have the velocity? You take the derivative and then you plug in t equals 5 in your derivative. That was a polynomial, so it was not too hard to find the derivative, and then the answer was 15 meters per minute squared. That was correct. There were two easy points to get there. First, finding the derivative, secondly, plugging in t equals 5, and that was good. The second student did the same. The way to write the units is a little bit different. Instead of writing meters per minute squared, that student wrote meters per minute. Both are acceptable, and the student earned 2 points. The third student said that the acceleration is the derivative of the velocity. He found that, or she found that correctly, then solved or plugged in t equals 5 correctly, and that student also earned 2 points. So quite a good exercise for everybody here. Finally, question D. Based on the model B from the previous part, find Bob's average velocity during the time interval from 0 to 10 minutes. The average velocity is 1 over b minus a, which is the length of the interval. Here it's 10 minus 0, so it's 10, of the integral of the function. It's a polynomial. The student here integrates the polynomial correctly, uses the fundamental theorem of calculus to substitute t equals 10 and t equals 0, simplifies, and find that the average velocity was 350 meters per minute. There were many points you could earn in this exercise. Writing the appropriate formula for the average velocity was 1, integrating correctly was worth 1 point, and getting the right answer was worth 1 point. Our second student wrote the correct expression for the average velocity, but then didn't go through and stopped there. It seems like they started something, but that's all there was on the paper, so it was only worth 1 point out of 3. Our last student had some vague memory of what the average velocity is. Sadly for the student, they didn't choose the correct expression. This is not the expression for the velocity, it's actually the acceleration that they found in question C. So if you want to find the average velocity, it's 1 over 10 times the integral of the velocity itself. So it's wrong from here, actually. Now let's look at this, because the student didn't stop here. That was 0 points, but the student continued to work with this. So if we look at what the student did, the student integrated correctly, substituted correctly, simplified correctly, and got this answer. This time, however, he earned no points. So the FRQ evaluators decided that if the setup was wrong, you could not earn any of the following points in this question. So some common mistakes that were done in this FRQ among all students around the world. Let's read what is written here. In general, students performed well on this problem. Tabular problems like this have appeared on recent AP Calculus exams, and teachers seem to be preparing students for this type of question. This is almost an ominous comment. It almost feels like they're going to change something in the near future. In part A, the most common errors were simple subtraction errors. We saw an example. In part B, in the explanation, many students omitted either the time interval or the unit of meters. In the expression for the Riemann sum, some students used negative 220 instead of the absolute value. Some students found a left Riemann sum or trapezoidal sum. Just read the question carefully. In part D, many students used an incorrect function as the integrand. So that's what happened with our student 3. They put the acceleration instead of the velocity. Recommendation: since students made many arithmetic mistakes in this problem, teachers should remind students that unless otherwise indicated, numerical answers do not need to be simplified. This also suggests that students need more practice on problems in which a calculator is not permitted. Teachers should continue to practice questions involving all types of Riemann sums. Students should communicate Riemann sums clearly before calculating the final answer. This means, as I think all the students did in this exercise, they all did it correctly, that you are not allowed to just give an answer. You have to spell out this, everything that you do, so the area for each rectangle. I'll just go back so that we can see what I'm talking about. So here you have to show the work. So this line is necessary. You can't just do it on another piece of paper and write the answer. So in this example, all the students did that correctly. They all showed what they were doing. That's a general thing in the FRQs. You have to show what you're doing. If you're working with a calculator, you have to set up the equation and then you can solve it. Thank you.